Hey ladies and gentlemen, welcome to your review sheet for Chapter 1, Chapter 2. Hope you're having a good day. Pay specific attention to the absolute value problems, but let's get rolling here. I'm going to solve each equation below. So first I'm going to distribute is negative 6 into 4 and negative 6 into negative y. So I got negative 6 times 4, which is negative 24. Negative times a negative is positive, 6y. Rewrite my negative 18 minus 2y. I'm going to combine like terms. I'm going to get 7y minus 24 equals negative 2y minus 18. Don't be upset that I switched that over. I'm going to add this 2y over. Then I'm going to add 24 over. Okay, so this is 9y equals 6. So y is going to be 6 over 9, or basically 2/3. That's the best answer. Coming over here for number 2, okay? You want to isolate this guy here that I'm highlighting. You want to get that by itself. So to do that, I'm going to subtract 8 over. I'm going to get negative absolute value of 10 minus 2p equals negative 1. And then divide by negative 1 to make it a positive absolute value. So I have absolute value of 10 minus 2p equals 1. Now, this is the part where people go awry. The positive 1, people never forget. Because they usually just dish the absolute value and go through this. So I'm going to subtract 10 over. Negative 2p equals negative 9. Divide by negative 2, this is 9 over 2. Or 4.5. There's one answer. Here comes my negative answer, which is going to be 10 minus 2p is equal to negative 1. So I'm going to subtract the 10 over, get negative 11, divide by negative 2, this is 11 over 2, or 5.5. There are your two solutions. So let's get moving here. Let's go through 1 and 2. Notice I got interval notation at the end. But let's just start here. I'm going to subtract 4 from all 3 of my columns. This is negative 9 is less than or equal to 3a, which is less than 8. Divide everything by 3. Negative 3 is less than or equal to a, which is less than 8/3. Now, as far as your number line goes, here's negative 3, here would be 0, here would be 2, here would be 3. Close circle at negative 3, open circle at 8/3, a is between. So, I'm putting this in interval notation, okay, which is what I'm asked to do here. We will start at negative 3. That hits a bracket. From negative 3, we will continue all the way up to 8/3, and that's where you will stop. Now, 8/3 is an open circle, so you would put a parenthesis. That's your solution for number 1. Number 2, start by multiplying by 3 both sides. So I get the absolute value, x minus 5 is less than 12. Positive 3. Now, again, absolute value is by itself. You now break it apart. This is my positive value. So x is less than 17. This will be my negative value. Remember to flip the sign. I add 5 over, I get negative 7. So, on a number line, what this looks like is the following. Okay, open circle at negative 7, open circle at 17, and I am greater than negative 7, but I am smaller than 17. So, interval notation, we start at negative 7, that's my smallest value. I put a parenthesis because it's open. This will continue up to 17, and then stop. Voila, there is both your inequalities in interval notation. Okay. Jumping down here for domain. Remember, you cannot divide by 0, nor can you know square roots of a negative. Okay. This has 2x plus 8 on bottom. There are no square roots, so you don't have to worry about this one. You do have to worry about that one. No division by 0. So what will make this 0 on top? Well, 2x plus 8 equals 0. 2x will equal negative 8. X is negative 4. So this is the value you cannot have. So if you're asked what's the domain, you would say all real numbers except when x is negative 4. That's a no-no. How does that look in interval notation? Well, think of it like this. This is a number line. Everything will work on this number line except for this guy at negative 4. So if you put that in interval notation, this graph here, you would start at negative infinity, and you would go up to negative 4, stop at negative 4, and then jump on negative 4 again and go to positive infinity. So what this says here is everything works but negative 4. Okay? Number 2, no one should miss this. You're just putting in negative 3 for your x values. So
pardon the interruption. At this time, all juniors should report to the auditorium. At this time, all juniors should report to the auditorium.
Well, now that you heard that announcement, life is complete. But basically, put negative 3 in. Negative 3 squared is 9. Okay? 4 times negative 3 here is negative 12. 9 minus 12 is negative 3. Negative 3 minus 7 is negative 10. That's all you have to do. Let's take a look at the back page. Okay? Starting with part 4 of graph 1. I'm going to use slope-intercept form, which it already is in. There's my y-intercept. This is rise. This is run. So you always run to the right, and I'm going to rise up 4. There's your next point. So over 3, up 1, 2, 3, 4. Over 3, up 4. If I go backwards, it's over 3, down 4. Okay, solid line because it is the equal to. There's my graph. Okay, starting with this one. What I'm going to do here is subtract 3x from both sides. And then going to divide everything by negative 2. So when I divide everything by negative 2, you have to know to flip that sign around. This is positive 3 over 2x plus, I shouldn't say plus, should I? It should be minus. So again, this is what I'm going to use to graph it. Negative 4, which is down here. This is my rise over my run. My rise is 3, my run is 2. There you go. Over 2, up 3. Over 2, up 3. Over 2, up 3, and so on. Back 2, down 3. Okay, it is a solid line because there's an equal to. If there was no equal to, it would be dashed. Greater than. Shading would be above. So we're shading up here. Okay? There's your graph for number 2. All right, we're on to 3, inequality. Well, let's just say absolute value. Best way to do this until you're familiar with how the vertices work is to actually just go ahead and just start putting numbers in and testing. If you put 0 in, 0 minus 3 is negative 3, which is positive 3 plus 2. Put 1 in, negative 2. Absolute value, that's 2. 2 plus 2 is 4. Put 2 in, negative 1. Absolute value, that's 1. 1 plus 2 is 3. Put 3 in, I get 0. 0 plus 2 is 2. Put 4 in, I get 1. 1 plus 2 is 3. And you can see this is going back up. Okay, so at 0, I'm up 5. Okay, 4, I'm up, I'm sorry, 1, I'm up 4. At 2, I'm up 3. At 3, I'm up 2. And then I start heading back up. Okay, at a slope of 1. So here is your absolute value. And you're finished. Your vertex is at 3, 2. I know I didn't say you had to label it, but be aware of that. So think opposite, same. Okay. Number 4, piecewise function. This is your battlefield right here. So at this point here on the x-axis, this is where they're going to kind of overlap. All right, so let's go with the left one, which is the top one. So I'm going to do this equation in ring. So start at 1, number smaller than 1 would be 0 and negative 1. If I put 1 in here, I get 2 minus 3, which is negative 1. If I put put 0, you'll get negative 3. If I put negative 1 in, you'll get negative 5. So 1 down 1, and it is a closed circle because it is equal to, closed circle, 0, negative 3, negative 1 down 5. Okay, and that's my slope of 2 basically. So there's my first line. Second line I'll do in blue, which is this guy. He's greater than 1, so I'll go 1, 2, 3. If I put 1 in, I get negative 1. If I put 2 in, I get 0. 3, I put in 1. 1 down 1, that would be an open circle here. Let me touch that up. Since it's already closed in by the other one, it still kind of counts from the last one. But for this blue graph, it would be an open circle. And then you have a slope of 1. So there's your graph, or x minus 2. So you're finished with number 4. So blue one was going to the right. This maroon one was the one going to the left. Okay? All right, part 5. Slope. Slope is the difference of the y's, y2 minus y1, over x2 minus x1. This is x1, y1. This is x2, y2. So when we do this, this should be 7 minus 9, negative 2 plus 6. Because I subtracted negative 6, guys. That's why it's plus. So your slope is negative 2 over 4. M is a negative half. Please reduce. We're in high school. Do not complain about that. Just understand that that's now expected. Okay? Write an equation of a line that passes through slope-intercept form. Okay, so I have the slope. Now I need the intercept. So I'm going to use one of these points. I'm going to pick this one. You can use either one. They give you the same answer. So 7 will equal a negative half times negative 2 plus b. So this would be 7 equals 2 times a half is 1, negative times negative positive. So b will be 6. Okay? This is supposed to be a 6 here. It looks like another b. So your final equation is y equals a negative half x plus 6. Final answer. All right. I'm going to jump down, passes through this point. Here's x, here's y. Parallel to this, this slope is negative 3, so our new slope will be negative 3 as well. So y equals mx plus b again, like we did in the last one. This will be 2. M is negative 3 times x, which is also negative 3 plus b. So 2 equals 9 plus b. This is negative 7 for b. So your equation to finish is negative 3x minus 7. There's your answer. Okay? So be aware, this is parallel, they have the same slope. If it was perpendicular, which it will be on the test, you would take this slope and your perpendicular slope to that would be positive 1/3. So you flip it, you flip him, it's negative 3 over 1, and then get rid of the negative. If it doesn't have a negative, you need a negative. So it's the opposite reciprocal, basically. And that's the slope I would have used it here. Okay, be aware of that. Going to your word problems. Lauren traveled for 6 hours in her car at a constant speed of 120 kilometers per hour, then traveled in a bus at its constant speed for 3 hours, 20 minutes. Okay, if the total distance she traveled was 1,000 kilometers, what speed was the bus? So, we got car. Car's rate was 120. Time. How long was she in the car? Does it say? 6 hours. Good. So we got everything we need there because distance equals rate times time. Let's talk about the bus. The rate the bus was traveling, do we even know? Travel at a bus constant speed. All we know is it's a constant speed, we'll use x. 3 hours and 20 minutes. Ooh, be careful. You have to convert 20 minutes to hours. Well, there's 20 minutes that you're looking at, and there's 60 minutes in an hour. So to convert it, that would be 1/3 of an hour. 20 minutes is 1/3 of an hour. So this is 3 1/3 of an hour. Now, total distance. Well, this distance to this guy is, I'm going to make that actually